So we have 7 layers in this model. Layer 1, 2, 3, 4, 5, 6, 7. So just have a look the name of these layers. Here is the data link layer. It will take the data from the upper layer and will add some header and head and tail, right? And then it pass to the physical layer. Physical layer then transmit the data to the other side, and it will goes to it. Now we have to discuss everything. How this is transmitted, what are the issues will be there, will be actually in our course. We will see all the protocols and all the issues will be discussed. But before that, we need to understand the overall structure, and we need to get an overview that how the things actually happening, and then we'll go into detail. So far we've understood that the things are happening in the form of layers, and the upper layer provides the data to the down layers, and down layers are keep on adding some header to it and passing to the down layer, right? So here we get the information from the upper layer. It will add something, some bits are added, and then pass to the physical layer. So the question is, what actually is the job of this layer? What this layer is doing for us to make this communication possible? Now these are the concerns. So if you look at this, we have some machines which are connected to internet. We have different networks which are connected to routers. Now one thing to remember here is, when we talk about the data link layer, the communication is actually happening hop to hop. Okay, not end to end. Hop to hop means the communication with the immediate machine, immediate device. For example, this is your sender, the receiver. This communicates with this only. It will not communicate to the receiver. It communicates to the immediate device, that's the router, which actually in the path. This communicates with this communicates with this. So the data link layer will provide to the physical layer. Now some information will goes. Now this will have 2 ports. One is input port and output port. It takes the data, change some information which is required to deliver to the next router, and then forward it to the next router. And this is happening until it reaches to the receiver. So the point to note is, hope to hope delivery is happening at the data link layer. Now what are the different things which are actually this layer is responsible? So these are the different concerns. Framing. Framing is a name given to the packet. When the data comes from the network layer, goes to the data link layer will add some header and trailer, and this is called frame. Here we will use different names for this stream of bits. For example, when I am data link layer, I am calling it frame. Sometimes I call it packet. Sometimes I call it datagram. Sometimes I call it segment. So when I say frame, that means I am talking at the data link layer. My data is at the data link layer. So the framing is done here. In the framing, we are adding the header and trailer. Then physical addressing. Physical addressing means to find out the physical address, the MAC address of the next machine. That means if this machine want to send the data to the receiver, then it is the responsibility of this machine. Means this machine data link layer has the responsibility to find the MAC address of this router. Now how this is done? If I want to send a message, to my friend who is sitting somewhere in US, then how do I know that how many routers are actually coming in my path? Everything is possible. We can easily identify this. All the routers we can find out, their IPs we can find out. Now the question is how to find the physical address of this. Okay, so physical address need to be identified. Physical address means MAC address. We have different kind of address. We have physical address, we have logical address, we have port address. So this time I am talking about the physical address, the MAC address. So this has to be identified. How we can do this? With the help of some protocol. We will also study this, that how this is to be identified. So this will identify the physical address of its own machine, of the sender and the receiver. So who is the receiver? This machine is the receiver. And the flow control. Flow control means Flow control is a kind of mechanism that assures that there is a compatibility about the capability of the two machines. What does that mean? I will repeat in the other sense. If one machine is sending 200 bytes of data, okay, but the other machine is not able to receive this amount of data, it can only process 2 bytes of data at a time. I am sending 100 bytes, it can only receive 2 bytes because it has no capacity to process 100 bytes. So what will happen? The data I am sending it, but actually it is not used by the receiver and it will be getting lost. So it is required that there must be a compatibility. It should be known in advance to me that what is the capacity of the receiver, and accordingly I will send the data so that there will be no data loss. So if there is no flow control, then definitely there is a data loss because of the incompatibility, means the two things are not compatible, their speeds are not compatible, the processing are not compatible. At the same time, the other disadvantage is there is a lot of congestion happening in the network. We are sending the data, it is not used by the receiver, and unnecessarily we are adding traffic to the network. So flow control is this thing. Then error control. Error control is to make sure that the information which is delivered from one side should be reached accurately to the other side. So we have to take some measures. Okay, if I am sending some data, when you send the data is not delivered like let's say if I am sending a data of 1000 bytes, then these 1000 bytes are sent into small chunks. 1000 bytes may be delivered into 100 into 10 segments. Now, how to make sure that all the 10 segments are reaching at the other side? One thing. And how, even if they are reaching in the order? Because if you change the bits, then the meaning will change. Is it? So everything has to make sure that all the data must reach and it should be reached in the proper format. So this is error control, to control the error so that the receiver will get the accurate information or the correct information. And then comes the access control. Access control means this is the responsibility of the data link layer to identify which resource will get the access if there is a multi-point connection. If one channel is shared by multiple devices, then who will get the access to the channel? It is also determined by the data link layer. One channel, 5 machines are connected. So actually, turn by turn they are using this channel. Let's say we are 5 machines and we are using one channel. So first I will use, then she will use, then she will use, then she will use. Okay. Now it's not like a sequence that first me, then this, then this, then this, then this. There is a defined kind of rule. Let's say she is idle. She is actually not doing anything. Then why should she get the chance to access the channel? You understand? So there is a kind of some rules are there which defines that how to access the channel. If it is a multi-point channel, if the channel is shared among the devices, then which device will access the channel? How to determine this? This is determined by this data link layer only. Naming is a name given to the packet at the data link layer. The structure of the packet which you are delivering to the physical layer, that structure at the data link layer is called a frame. So how you can define that the information which you get from the network layer, when you add some header and trailer to this information, that becomes a frame. So the frame is a name given to this data at the data link layer. Now when I go to network layer, when I go to the transport layer, when I go to other layer, session layer, I will give different names. So if I say frame, that means we are at the data link layer. Is that okay?